My name is Bradesko. I'm the founder of DoubleJump Academy. This here is Corbin Main. He's the co-founder of DoubleJump Academy and my partner in crime. So we're gonna have a split presentation. I'm gonna do the first part, and then Corbin is gonna show you some cool advanced disintegration setups. I'm gonna do a quick intro, overview of what is DoubleJump Academy. Then we're gonna go into some cool explosion emitters, and I will do a sneak peek on the explosions workshop that I'm doing. And then we're gonna have a world premiere trailer here at FMX. So I'm very excited about that. So what is DoubleJump? I get this question a lot, and it's so funny. Right after, I think it's 4 months ago, we started the Academy, and this video came out, and it perfectly sums up what is DoubleJump.
You can easily make that.
How?
Double jump.
What?
What?
Double jump?
Yeah.
What's that?
What? Say that to me one more time.
Say what?
Ask me that stupid question again.
What's double jump?
What's double jump? Are you serious?
Yes, Ben, I'm serious.
It's like a jump, but double.
Oh, fucking perfect. Now I get it. Great explanation, Ben.
Okay then, look, I'll break it down. You ready? Okay, you ready?
Okay.
It's a jump, and then, wait for it, you jump again.
So
you get double the height or the length. It's what's gonna happen, all right?
Okay.
I am gonna double jump over this gap and get the f on with my life.
Okay, so you're just gonna jump to your death, are you?
No, I am gonna double jump the gap. If you wanna mooch around on this side of the chasm for the rest of your
I'll
life,
find a
go
way
for
around.
it.
I'll
Go
go
for it,
find
mate.
a-
I don't care.
What are you doing?
I'm gonna double jump.
Oh. What whoa. What was that?
A fucking double jump.
So I think it's clear now. Well, you know, I think you guys know what a double jump is by now. But essentially, that's what we do for our instructors and for our students. We are that second jump. We help you reach the next level, like the height that was previously unreachable. So I think our main goal is to really empower great artists and to empower amazing educators. And we do that, like our main mission is to provide the educators with the best possible platform for them to teach and then give the students the best education possible. And we do that one workshop at a time. I really believe, especially now in these times, that through education and sharing our knowledge, we can do a really big and like a big positive impact on the industry. So this is our website. We have a bunch of free workshops. Some of them are paid, but we're doing a lot of stuff. And I was really excited. At the beginning of the year, we released the Attack on Titan sequence. I'm going to show you more about that in a second. But it was that workshop is powered by SideFX. So thanks, Chris, for believing in us. But I think SideFX is really one of those companies who believe in the community. And that's what DoubleJump is as well. Everything is based really on the community aspects of community #1 priority every time. This is how our wiki looks like. So if you want to be an educator with us, if you want to teach a workshop, we have a whole onboarding process. You know, we have workshop manuals, we have video workbooks. We help you with your business plan. We do the marketing for you, all the designs. We work with you as a private agency, essentially, making it as easy as possible for you to do the workshop and then teach it to the world. We also started our community files. The goal with this is that we're gonna collect the best projects from the best people around there and just make a very useful project community library and assets. This is something I'm thinking about doing, but it would be a crowdfunding initiative. So if you do have, if you want to do a smaller tutorial, or if you want to share your project files, we essentially almost want to do like a small Kickstarter on our website. So instead of going to Gumroad and maybe getting a few sales or going into a Patreon, you do it with us, and we already have an established community. So it's a win-win for everybody at the end. And we also have a talent discovery page. So if you're looking for a job, the recruiters and recruitment teams are actively looking at this list. And we also link you with the recruiters if we see you as a good fit. All right. So this is that Attack on Titan workshop I was talking about. So let's quickly take a look at what we did. Sweet. So this is the team that made this. It was a small studio called Opposite Visuals that did most of the CG stuff. And like I said, collaboration with Side Effects. I'm happy to say we are already doing a new project. It's going to also be anime-based, and it's going to be even bigger and better. So super excited for that one. But we made a whole workshop on this. So actually, we have, I think it's like 8 or 10 hours of video tutorials on how this was done from beginning to end. So if you want to see how something like this is made, we made it available for free. So go check it out. The Explosions Emitter. All right, so the explosions are my bread and butter. That's something I really like talking about and doing. So me and Corbin, we're going to do a tool set, essentially. It's a tool set all about explosions. This is nothing revolutionary, but it's just going to make things a lot easier and faster. So this is an explosion that I did, and this is using the grains emitter. And this is it was quite high res, but then I ran the low res version as well, and as you can see, it kind of looks the same. You know, the movement is the same, the shapes are kind of the same. The simulation is not going to change a lot because the movement, shapes, and the overall look of the explosion is done in the emitter. So I really, really believe that the emitter is like 80% of the work when it comes to explosions, unless if you want your explosion to be completely random. Because I know that previously I was just using, let's say you noise up a sphere and then you pump a lot of pressure into it, you put a lot of turbulence, and you can get lucky and get a good explosion. But with this, you are going to get a good explosion every time. So this is the grains emitter, different versions, different types of the emitter. And we're going to do a bunch of different presets, and it's just going to be super easy for you to create sexy explosions. That's how it looks like when you sim it. So even this kind of looks cool as individual elements, but then you can start combining the elements. And by combining layers, that's how we achieve complexity in effects. That's another, oops, no, go back and play. Damn it. PowerPoint is more difficult than Houdini. So here I added an RBD element as well. And this is, again, the high res. And then when you sim the low res version, it looks pretty much the same. And this took like 20 seconds to sim. So the emitter, the whole tool set, is going to have 3, maybe 4 modes. So the grains, and even the grains is going to have a bunch of different presets. Then you have the RBD, and then we're going to have the animated particles driving everything. And this is another example of, I think it's a very cool explosion. OK, so I'm going to switch to the second presentation. Literally 5 minutes before the talk, I had a technical issue, so I have to do this. All right, are we back? We're back. So we're also going to give you a bunch of different options on how to source your emitters. You can do whatever you want, just plug in your points, but we're going to make it easier for you to source and create a sequence of explosions. So let's say I just saw Hudson's presentation where they had a whole spaceship exploding. You just put your points there, and they're going to explode, and everybody's going to be happy. So it's going to be very flexible for you to do your explosions. So this is the RBD pass. And then we're also going to do another pass, which is the particles, kind of particles hanging up in the air. I was working on a project where the director said, oh, you need to noise up, you just dirty up your explosion. And I never knew what that meant. But essentially, what it means is have color variation in your explosion, or just add particles, add debris, add actual dirt. That's how you make the explosion more complex and memorable. Here's another view of that. And this is all using that grains emitter. And like I said, super easy. This took like 5 minutes to set up, and you get something that looks very complex and difficult. Something that maybe you would get like 2 weeks to do in a studio, you can now do like literally over lunch. So. All right, in the explosions workshop, we're also going to talk about shaders. So this is the shader we're going to do together. And I'm happy to say we just converted it to Material X. So it's extremely fast. And I know Houdini has this already. But I just like having my own shader where I essentially know where everything is. And that makes my life much easier when I want to change something. Because if I dive into one of the native Houdini shaders, I just get completely lost. So in the workshop, I'm gonna show you how to do all of this. We're gonna build all the emitters together, so it's gonna be a good time. All right, so the Ultimate Explosion Workshops, it's 4 of us working on it, and we are the Fellowship of the Explosions. So we have Yulen, Ismail, me, and Ayush. And honestly, this workshop is gonna be so freaking huge that I would never be able to finish it on my own. And I don't even know how I'm going to teach everything. Why am I doing this? And one of the reasons we are even able to finish this is because of Grid Markets. They're helping us with their rendering and simulating farm support. So, sneak peek. Are you guys ready? I hope you didn't blink. That was fast. But no, seriously, let's do a proper sneak peek. So it's gonna blow your socks off, okay? It's gonna be awesome. But essentially, it's this is like 50% of the workshop. So we recreated those shots. Those shots are not from movies, even though in some cases they look like it. And like I said, I don't know why we're doing this at such a scale, but I really think, I called it the Ultimate Explosion Workshop. That's what it's gonna be. And now we have a world premiere for one of our new workshops, and I'm just going to play it.
Have you ever wanted to learn Houdini? Houdini! To unlock the magic of the greatest VFX software in the world, used for blockbuster effects in the world's biggest movies, but have heard rumors that it's too hard or complicated to master. It's only for smart people, it's for geniuses. If you answered yes, I made a course just for you. My name's Jordan, I'm a VFX artist from Corridor Digital, where I use Houdini every single day. And I want to teach you all about it. I just want to talk about it, honestly. I love it. You see, I heard the rumors about this software too, and I held off for years out of fear that I wasn't good enough or smart enough, because the reality is I'm not special. No, I'm not super smart. I've never been good at math. I know nothing about coding, so surely I can't use Houdini, right? You're dead wrong. You see, Houdini is a technical software, but you do not need to be a technician to use it. It can be approached from the perspective of an artist. That's all right, baby. It's why I started anyway, on a journey that has quickly become the most fulfilling and addicting of my artistic life. And I want to help you do the same. Heck, it's why I created this course. It's the one I wish I had when I was getting started, a digestible, approachable, and achievable introduction to Houdini. This course will be your first day of school tour, so no previous experience is required. We're gonna be looking at particle simulation, liquid simulation, rigid body destruction, soft body simulation, crowds, hair, cloth, smoke and stuff. What would make things go boom? What would make things get all wet? Oh, my hair. We're gonna be modeling things procedurally from scratch and get into rigging and animation, taking a look at the full spectrum of what Houdini has to offer. But most importantly, we will be looking at how Houdini thinks, because it's different than any other software. And once you unlock that, everything else starts falling into place. And you will not be doing this alone. We'll have an active Discord taking questions, having conversations, and exploring and learning together. If you've got the will, I'll help show you the way. So join me, and together, let's unlock the magic of Houdini. Houdini!
It's pretty good, right? So that's it for my portion of the talk, but I really, like I said, I really think through education and sharing our knowledge, together we jump twice as high. All right, that's it.
Awesome. All right. Hi, everyone. So as Urban said, I'm going to be basically showcasing for you guys just a little teaser of something that we've got in our new film effects course. And this is actually just even a small part of part 1 of a 3-part giant workshop, which when we started filming it, like we had no idea how long it would take. And part 1 is like 22 hours.
You recorded 20 hours.
Yeah, 20 hours. So yeah, it is extensive. Because I just can't help myself explaining exactly how things work, which, you know, if you're into that and understanding exactly how it all works under the hood, then it's probably the course for you. So I want to show you something that I thought I could condense into a very quick presentation, but you would be able to actually walk away with something really useful about just how to think about setups. So the setup I'm going to show you is extremely useful in itself, but something else that you could take away from it is just the thinking about how to make your scenes more efficient and optimized. And like, I know that word efficient, it sounds a bit boring, you know, like we want big explosions, and thinking of efficiency is a bit boring, but you know what else is even more boring? Is waiting and waiting for scenes and sims. And the amount of times I've been asked by, you know, an artist on my team, oh, can you help me? I'm struggling with this effect. And we go over and try and work with the scene to see what's going on, and it's just like pedaling through mud. You know, it is like you can't scrub. You change a parameter and you got to wait a minute for it to cook. It is just horrible. And this is even just like senior artists as well are not optimizing their scenes so that they can keep like that creative flow going. It just grinds to a halt. So I want to show you guys how to think not only about how to build your setups better, but also more efficient. So this is part of a disintegration setup, and as you can see, there's a whole lot going on to it. But really, to disintegrate a character at its root, the main thing we're breaking it down to is the decay map, or it's basically a growth map, right? So we're setting an attribute on certain points, whether we're painting it manually or maybe setting it based on something else. And then we want those values to spread across the surface. And this is something so common, and I mean, if you haven't done a disintegration yet in your career, I guarantee you will as an effects artist, like a rite of passage. And in fact, it's an extreme example, but I think on Sandman, we did 5 different characters disintegrating in different ways. It was crazy. So, but there's also like, blood spreading from a wound, fire spreading across like the floor, you're going to have to spread attributes, right? But the way it is most commonly done is atrocious, and I'm going to show you why. All right. So I've just got a really basic setup here. So I've got a character. I've isolated the head so we can kind of just keep it light and optimized, and I've scattered some points on the surface, right? So you don't need to kind of know that beginning part. You'll have your own character. You'll have your own points, right? Now, the way you would usually have an attribute spread is, of course, you set an initial attribute, and then every frame, we would just, inside of a solver, you would basically find your nearby points, fetch values from there, and kind of add it to your own value, and maybe clamp at a certain point, because you want to kind of say, okay, I'm going to decay from 0 to 1, and once I hit 1, I'm like fully decayed. All right, cool. So nothing really crazy going on in here, just inside of a solver, and then we write out those frames. So this is the most basic way to do it. It is also a terrible, terrible way to do it. So put in my cook times over here. Obviously, these are not massive numbers, but that's because I've only got 1 million points, which is not a lot in Houdini, obviously, and it's just the head, okay? But just for comparison of all these 4 different methods I'm going to show you here, you can see how we're going to actually optimize this, right? Now, there's a lot of problems with this setup, a lot of reasons why we don't want to do it this way. And the number one, and this is the thing that I really want you to take away, is time dependency, right? I guarantee you, go check your scenes at home, time dependency is screwing you over, right? That is why I usually make the actual time dependency flag huge, so I remember and I can see where my time dependency is coming in. The reason why is because basically, as soon as any node is time dependent, every node after that is going to remain time dependent, even if it is only calculating something that it needs to just basically cook once, right? But the next frame, it has to cook again. So it absolutely kills the efficiency of the setup, right? So time dependency, number one, and I'm going to actually show you an example just now of how badly that destroys us. Then also, things like, okay, so let me actually show you the results over here of what this looks like, right? So of course we're spreading this attribute. So, you know, we start on the beginning, we've got a few values and it spreads, okay? So yeah, you've all seen something like this. But now also, we really have to start like fiddling with these settings to get it right. It is not art directable. And I mean, as a junior, I did this where we had a disintegration and it was, I mean, like 50 iterations with the director because it's like, oh no, on this frame I wanted to have like reached, you know, her cheek, but not actually covered her face yet because she still needs to like deliver a final line before, you know, a little tear before she then disintegrates. And you're like, you know, so you're playing with timing and then you're fiddling with settings. You have to recache, resim. It's horrible. Also, because this is time dependent, we're caching every single frame. So, I mean, it is just a terrible, terrible way to do decay, all right? And the list of good things it's simple, you know? That's all I could come up with is just basically there's no really redeeming quality of doing it this way. One way to get around, I guess, the art directability is that you can retime it. So I do admit that, yes, you can retime, but the problem then is that your duration is baked. And what I mean by duration is basically, you see here we're going from like blue to red. The kind of the fall off between that of how long a single point takes to get from when it begins decaying to when it actually is fully decayed, that is baked in. So if we retime, then that gets retimed along with it. But what if we want to keep the duration the same, but we just want our start and end to be shrunk down? So it must spread quicker, but each point grows from 0 to 1 at the same rate. Well, we can't do that because they're baked together. So we've built up a nice strong case of why we're not going to do it this way. So now I want to show you guys how to think about better ways to do your setups. And this is actually sort of what really a lot of the course is about, is like thinking smarter and better, which is also similar to what Jordan was saying about Houdini, is like understanding how it thinks is the way. So the first thing we're going to do is try and get rid of that time dependency, okay? So instead of doing it live and having to track a value that is changing, what I'm going to do is essentially just mark on every point when it hits the final decay. Okay? So we're just going to use a solver, keep adding those values, but once it hits 1, that's when I want to basically say, right, remember what frame you reached 1 at. So I'm going to set an initial value of -1 so I kind of know what my like default is. And then in the solver, I'm doing a very similar spread, but I'm doing another step where I'm basically saying, once you have a value of 1, we can create a group and also store that frame number of the frame where you entered that group. Okay. So then we time shift. So instead of having to cache all those frames, we now have only a single frame cache because we've essentially compressed it all. And we now end up with a result that is a single frame. Nice and easy. I mean, this is 600 frames, and I didn't even reach the end. So you can imagine how many frames we would have, especially if we had the full body, right? And obviously, this is not moving. There's nothing changing, and the decay values are no longer changing. But what we have is essentially this decay end, which what you can think of this as is like it's a gradient, right? So from our values that we started with, it's going to spread. And in this case, I wasn't actually adding much noise or anything when it spreads, but you could. So the gradient might not be so smooth, but still, it is essentially saying these points decay before these ones, and these ones before these ones, and so on. And now you can refit that to whatever frames you want and have total control without having to go back to the cache, right? So we'd run that once, we cook it once, and now with just a little bit of code, which obviously if you don't know Vex, I mean, we cover it in the course and we'll teach you, but this is actually not as complicated as it seems, and you could do this in a VOP as well, really simple. You're basically just taking, you know what your start frame is, you know what your end frame is, because you've time shifted all the way to that, and now you basically just refit that, and you can slide it back and forward on the timeline and say, okay, well, so I'm saying from frame 1100 to 1300, I'm going to decay. So now let's switch back to our decay values over here, and you can see that, well, let me just go back into our update. Right, so then we see we're spreading those values, but now I can control, without having to go back, I can just say, all right, let's make this end a few frames later. Or maybe we want the duration to be really, really tight, like it was in the first version. So just reduce that a little bit. So I've got that. And that's all just live. I can just scrub back and forward and control this, and the director says, no, actually, I need a couple more frames in this, and just say how many you want. And like, he could be standing right next to me and just controlling this. Okay. But one of the main benefits of this is the fact that this is non-time dependent, our cache, and then this is time dependent. In this gap, we can insert a whole bunch of work. And in this case, what we're doing is we're taking all these points, we're putting it through vellum, so like we're turning them into grains. We could create explicit constraints. There's a whole lot of work that we could do this. And even our constraints are based on things like clumps and bone like shards and things, so we have to do a whole lot of very expensive work, but that only needs to be cooked once to set just a bunch of attributes. Even just the vellum constraints nodes themselves are quite heavy. Like, they may take like 5 seconds or 10 seconds to cook, which doesn't sound like a lot, but if that's 10 seconds every frame, that's a lot of wasted time. Whereas now we can just put this right before the solver. We just reintroduce our time dependency, and then we pop into the solver, okay? All right. So we have a similar cook time in total, but obviously we have a single frame that we've cached out, so we've fixed a whole bunch of problems. Like all of this time dependency, the duration being baked in, all of that is fixed. The only problem is we've introduced kind of a new problem, which is that we're selecting a very specific frame to time shift to, which means, and in this case, it's actually a perfect example. You can see what's happening at the back of the head here. We didn't have enough frames to actually let it finish. So those values at the back there are -1, right? That's why they're doing weird things, okay? And of course, we could time shift further, but now I have to go and recache, and I have to figure out and guess, and did I do enough? And then maybe the geometry changes, or we stick more points in there, and now I have to start guessing again about how many frames. And if I overcompensate and say, well, let's just time shift to 5,000, now I'm cooking frames that I don't need to, just to boil it down to a single gradient. Not a good way to work, okay? I don't like guesswork. So we're going to break away from this whole like solver thing. I mean, there's no real reason. If we're time shifting, why do we need it to be based on frames, right? Let's just make it, what it is really is it's an iteration, right? It's a loop, okay? So we're just going to use a loop. So moving over now to this sort of third version of this, we're going to say, okay, no, same thing. We set a decay end value, and now we're going to enter a loop instead of a solver. Fairly similar thing going on in here. I'm just basically fetching those values, setting it in a decay end group. So basically, once you've reached fully decayed, you're now in a group, and you remember what, but we're not remembering frame number now, we're just remembering what iteration of that loop we are on. And then the only extra step is to create a stop condition. So this is the benefit of a loop, is now we can break out of that loop whenever we want, and we can set whatever this condition is. So in this case, I'm basically saying once all my points are decayed, once they're all in that group, then let's just stop. So now I could set my iterations to 5,000, 50,000, it doesn't matter. And it'll keep running and then stop when it needs to, right? So it's really, really efficient. And actually, in doing this course, a couple of the students have pointed out to me that sometimes there's a few errors. Maybe there's a point that's so far away from the other points accidentally, the way it was scattered or something, that it never gets values transferred to it. And so this loop never hits the stop condition, never breaks out, and there's a problem. But you could easily add that into the stop condition, is just check whether anything changed. And if nothing changed from the previous frame to this frame in terms of your group, then you also break out, and then maybe even, report an error or something. So there's so many ways that you can make this like perfectly efficient that it will run exactly as many loops as it needs to and no more. And then we get the exact same result at the end. So, we've got a single frame cache. It's also got all the same benefits as the previous method, except now it works 100% of the time. It just spreads, and now you've got total control of decay based on just one single frame cache. In this case, it took a little longer to cook than the previous one. Maybe we could sort of optimize it to get it to a similar number, but we're going to even improve on this. And you can see here, I actually wrote down how many iterations it actually went. So even though I set it to 5,000, we've gone, right, based on the stop condition, we're only going to run 1,154 loops, and then we need to break out because everything has a value. So lots of benefits. Efficiency is still a problem, though, because I feel like, so we were talking about how time dependency is problematic, because what it's causing is things that could be calculated once are being calculated many times, wastefully. The same thing can be applied to loops. If you're doing anything iteratively, you need to be questioning whatever you're doing, does it have to be redone? Or could I have done this once before and remembered or stored some information and then just used it inside the loop, right? So what is changing versus what is just static? So when we're doing our search to spread these values, we're using a PC open function. So that's just searching for nearby points and gathering a handle of these points. It's a very, in fact, as far as I know, probably the most efficient way to kind of find points nearby, right? But it's because it's the most efficient way, it doesn't mean it's going to be the most efficient in our case, because with, like, basically, sorry, I'm just kind of losing my train of thought here. So PC open is really efficient, but we're doing it inside the loop. What we need to do is get that outside the loop. So before we enter, we're going to search for all our points rather than doing it inside. The reason why is because we know we've got static geometry, right? The character's in rest pose, because we are going to transfer this to the animated character later down the line anyway. So it doesn't matter. We've got a static character. So when that point finds its neighbors, let's say it finds 10 neighboring points, next loop, it's going to find those same 10 points. The next loop, it's going to find those same 10 points. And the neighbors are not changing, but the values are changing. So what needs to be inside the loop is the fetching of the values. But outside the loop, we're going to say, okay, find your neighbors and just remember them. But because of that, we can't use a PC open, or, I mean, we're going to use a near points function. Technically, you could use PC open, but then you'd still have to loop through it and build an array, which the near points function builds an array for us anyway. Because we can't store that handle, right? So we need to basically just store it as an array. Essentially, we're just telling our points, find your neighbors and write them down. Just remember, right, these are my neighbors. And because we're going to be relying on the PC filter function, right, usually, that is basically fetching values, but those values are weighted based on distance. So we just need to also remember the distances. So we say, right, find my 10 nearest neighbors, write them down, but also figure out the distance to all of them, store that in another array. And now with that data stored, which is less efficient than a PC open if you consider it for like one iteration, the efficiency comes in the fact that we only now need to do that once. So even slightly less efficient, but once, is then better than more optimized, but run 1,154 times, right? So now this is our most optimized setup. So inside of the spread, for example, here now, we're not doing the proximity search. Our points are not looking for their neighbors. They know their neighbors. They're just fetching values from them and weighting that based on the distance that is already also stored. So they're not having to do very expensive distance calculations. And all we're doing inside of here is we're essentially rebuilding what's happening under the hood of a PC filter function. Okay, so we're just weighting based on distance. And then all of the rest of that is exactly the same. So the result, same benefits, single frame, we're non-time dependent, all the same benefits, except cook time for that was 30 seconds. So we went from 4 minutes 30 to 30 seconds just by moving that loop, well, that search outside. And this is just on 1 million points. The thing is, if you increase the number of points and increase the number of neighbors that they need to find, because if you've scattered more points, then but limit the neighbors, then they're going to search a much smaller distance. So basically, as you up-res this, you have to have them search for more neighbors. That 30 seconds is going to look really, really good, compared to, because it's not going to be 30 seconds and 4 minutes. It's going to be more like 30 minutes versus 4 days, that type of massive, massive saving, because it gets exponential. All right, so the only bad thing remaining in this is that you have no excuse for missing deadlines, because your scene is really efficient, and you can now just literally cook that 30 seconds, or maybe for a larger model, it took me like a minute or whatever, and completely custom control how Decay works. And I did say I would show you sort of how efficient this time optimizing is. So I've got a version here where I've got her whole body cached, and here's basically 2 setups. This is how I was originally doing it before I then, wised up and started looking at the efficiency of it. And you can see all of these big time dependency flags. That's what you don't want to see in your network. Left-hand side versus the right is exactly the same nodes, just reordered. So nothing has changed, same nodes, just the order, okay? So on the left, I'm reintroducing my time dependency early. This would also be the equivalent of if you just used the first method. So even though this is that refit node, doesn't matter. What it means is we have time-dependent decay values. So now everything after this point, even this transfer, which the transfer is based on distance to a static object, so it should be non-time dependent. But because the thing it's transferring from is time dependent, it now has to cook every frame, right? So with that cooking every frame, our ID is cooking every frame. I'm doing a very expensive cluster operation here where I'm basically making chunks of flesh that are going to then peel away and sort of hold together in vellum. That expensive operation has to run every frame, the stop, and then the constraints. I haven't even introduced explicit constraints here, just grains. And already this is quite slow. So if I show you, I'm not even going to show you the solver, just the source, or going into the solver. If I hit play now and see how we're running, I mean, there's 21 frames per minute. Okay, so this is slow. I mean, when artists call me over and let's go, why is my sim so slow? It's like, okay, well, go and click on your source and see if you can play your source live. Because if your source is not real time, then of course your sim's going to be really slow. Right? Here's the exact same nodes, just in a different order. No time dependency. Let's transfer all of this. Let's do our clusters, which the cluster still takes the same amount of time to cook, but it only does it once. Grains, also, once. And now we reintroduce our time dependency. And the time dependency node itself was not actually ever really slow, but it was causing the nodes that are slow to be forced to be recooked every frame. And so now there's our source, and I can play that at, 7 frames a second. Okay. So it makes a huge, huge difference. Right. So I hope you guys will kind of take that away and learn something from that. Optimize your scenes, and definitely this, if you're ever doing spreading attributes, this is going to be the way. Cool. That's it.
Keep it simple, optimize. Any questions? Yeah.
Thanks. Hi, how does the file size grow with when you store all the attributes for the neighbors? And because if there's millions of points and you have to store arrays, 2 arrays for, now you say 10 neighbors, but what if you have to store 1,000 neighbors?
Yeah.
Does the file size of the BTO grow exponential as well?
I mean, it does certainly get bigger. I mean, I can check what actual size it is, but I'll have to compare it. But I mean, it is certainly going to get larger. But I mean, storing an array is not nearly as bad as storing and then the whole geometry with all of its attributes for another frame. Like even just one more frame. Unless you've got no attributes other than point position, then maybe. But even that, point position's a vector. So you'd really have to be hard-pressed to have like very few attributes versus an enormous array. And in my case, I was mostly checking maybe 20 points. So my array is about 20 in size, and obviously I've got a distance array as well. So I've got 40 values stored in 2 arrays versus even just a couple more frames of all those other attributes I had. It's always going to be more efficient. Yeah.
Great. Anything else? Great. Well, thanks, guys. Very good stuff. Oh, one question here.
Hello.
Hello.
I have a question with the disintegration effect. If you were to have the same effect, which is a really nice technique, on a dynamic element, how would you tackle that?
So when you say dynamic, so there's 2 aspects to that, because if we're just talking about the character is moving, absolutely you can do your decay and then transfer it on. But if you want the decay to sort of be triggered by something dynamic. So let's say the character's moving and it's whenever she like touches objects that stuff starts to spread up from wherever she's touched. Then what you would have to do is first go and run that as a separate sim to essentially figure out where your source points are. And then for probably each source point, you then want to run this same setup to essentially create that gradient from that source point onwards, and then you could combine all those gradients afterwards. So it's definitely much harder to do it if you have, we even discussed it in the course, but the example I used was, let's say a character being hit by like 3 darts that sort of spread some poison, right? Each of those would have to be its own gradient that you would then combine with like a maximum function or something like that. So you'd have to then either have 3 different attributes running through that same for each, or you'd literally have 3 completely separate caches that you'd then combine and do like a maximum. It's a bit of extra work, it's definitely more steps, but it's still way more efficient to do it that way. And you want to, if you have 2 separate points that it spreads, you definitely need to do them separately and then merge them afterwards, because it's like, remember I said the duration is kind of baked in. If you have these 2 points and then you start refitting and retiming the whole thing, then you're also moving when that initial value is started, because let's say you shift the timeline. Now, the initial frames are also shifted, so then the dart would hit and then nothing would happen, and then 10 frames later, then it starts spreading because you've shifted it. So you absolutely want every injection of new values needs to be treated as its own gradient. Then you refit so that that first frame remains fixed, but you're just scaling the other frames. And then you take those 2 results and you maximum them.
Okay, excellently explained.
Great. Any final questions? Yeah, Olaf.
Do you think it would be possible to do a similar setup that you did with the explosions, which is like completely time independent? I think you could go to any frame and it doesn't need to know the earlier frames. Here in the feedback loop, you still have some sort of iteration where it needs to know the previous frame. Do you think you could do a disintegration that is really maybe with a similar idea completely time independent? Have you tried something like that?
I mean, I have been thinking of ways to do that. Usually the way we've ever done it, we have done one before where it was completely time independent, but that was because we didn't care that we had what I call like islands of decay. So it's like so what we did is basically was just an animated noise. And then as soon as it peaks above a certain value, then that becomes decades, because then we can just do that wherever we want, and even in the sim, we could be triggering it. But then you can have things like it starts decaying from the hand, and then a patch starts appearing here. But you don't want that. If you want that sense of like organic spread, I think it's very difficult to have it not be time dependent in any way. I mean, what we're trying to do here really was kind of use time dependency once to calculate that gradient, and then freeze it and remove time dependency so that we can keep working. And what we've essentially done is created a gradient, and then at the end, we use the gradient to reintroduce the time dependency. So I think this is probably as close as we're going to get to completely non-time dependent if you want that organic spread. Because you have to like look at what's happening to my neighbors to figure out what I should be doing, And if they have a high value, then I should start taking a high value. If you make all the points completely independent from one another, and that doesn't really matter, then how do they know when they should start taking those values?
I mean, you still have a tree, like a data tree that is connected to each other, and obviously that's what you're doing, but you could use the connections, obviously, still,
Yeah, that is.
They're just not.
It's an interesting idea.
In the moment they start at a certain point, your connections, and then you go all over the object.
Well, it's actually funny you mention that, because we do have something sort of similar. I don't know if this will actually work or display in here, but so we built something. Hold on, let me just want to show you this. Well, actually, I'll do it with a blast.
Wow.
He's doing a live demo right now.
Yeah.
Very brave.
Jesus.
So this character has this kind of rig of just connections of points inside of it. This is we didn't cover this, but this, so it's separate. So what it is it's procedurally creating connections, but I started it from the feet where the weight is, and it spreads through and builds these connections, and then that is every point knows, it knows which direction it should spread values, so it's essentially a one-directional push, right? The reason we created this was I hate it when you start seeing decay happening and like the shoulder decays and the arm is still floating in midair and nothing happens. So where in this case, if the shoulder goes, it spreads down the arm really quickly, but if the forearm goes, it doesn't spread up the arm any quicker than normal. So that's what this is doing. Now you could kind of use that technique across all the points if you really wanted to.
You don't need that resolution. You wouldn't need
the
resolution.
I mean, with this as well, because the thing is you could transfer, if your points scattered into the volume a much higher resolution, but you only have a few points like this that just show the gradient based on connected polygons. When you transfer them, if you just transfer based on a noisy value rather than just point position, then you're going to get like much more interesting kind of organic shapes. So you can kind of get away with low res spreading and then a high res receiving point cloud. Yeah.
Great stuff. Well, thanks again, guys.
Cool.
Great work.